Thank you so much for having me here today. I really appreciate this opportunity. Normally, I'd start in with a whole bunch of statistics about how the Arctic is changing, how the weather is changing, our sea level, and what the Navy's going to do about it. I'm actually going to do something just a little bit different today. I'm going to tell you a story about how I ended up where I am today, and also how I've kind of gone on a journey here from being a pretty hardcore skeptic about climate change to one who believes this is one of the preeminent challenges of our century today. So if you want, in a nutshell, you can call this the Reformed Smoker Brief, if you will. What's that? Well, as it was mentioned, I've been interested in weather literally since I can remember. Second grade, first grade, kindergarten. I remember we moved. I was about 4 years old, and we finally moved into a house. We had 3 kids, and we could each get a bedroom. And I was the oldest, and there were a few privileges. Well, there's a bunch of privileges. But there were a few privileges, and one of them was I got to choose the bedroom first. And the reason I chose the bedroom I did is because it had a thermometer outside. And this was kindergarten. So it's been a little while since I've been interested in this. I was the kid who went to the library, who got all the books. In fact, the librarians gave me an adult card at like 9 years old so they would get me out of the children's section and go bug somebody else. I called up the Weather Bureau every day for about 4 years to get the high and the low temperature so I could write it down. They eventually got smart in Albany there, and they went and put that on a recording, so they didn't have to talk to this snot-nosed kid anymore. I don't blame them. About 10 years old, we moved down to Jamaica in the West Indies. And I'll tell you, there is no better experience than to take a kid, a white middle-class kid, out of the white middle-class suburbs and plop them down onto another country where, hey, in a 90-minute plane ride, you're a minority. It's a pretty good experience. And we could talk a lot about that, but the bonus for me was not only did I get to experience that, but I got to do it on an island that periodically got run over by hurricanes. So I thought this was pretty cool. This was good. And eventually I saved up enough money, and what I'm showing you here on the screen there, believe it or not, that is a picture of my very first rain gauge. Doesn't look like much. It's a cylinder. It's calibrated for a 5-inch funnel. So we went down to the market, and it was still in market back then, find the tinsmith and get him to build you a 5-inch diameter funnel. What he didn't understand is back then, I probably should have been a nuke because I kind of had this attention to detail thing. He built it for 6 inches. No, that was wrong. Then 4. That was wrong. We finally got it to 5, and that was perfect. So I set it up and put this whole thing like in a goldfish bowl because it rains a lot in the tropics. And what did we have? The longest drought we ever had in Jamaica. So I learned a little about weather modification even at an early age back then. Well, we came back eventually to America and grew up, and I knew I was going to go to some college someplace that did weather. I ended up at Penn State. I would love to tell you it looked like that big picture above, and it does now. But what it looked like more when I was there was kind of the picture down at the bottom. Yes, it was papers. Yes, we had maps, and it was great because there I learned that I wasn't the only one like me. There were a whole bunch of people like this, and this is way before being into weather was cool or into science. There was no Discovery Channel. There was no Weather Channel. There was no Storm Chasers. There was no Jim Cantori. This was a little bit before. And like many people, I was kind of worried about how do you pay for college. It's a pretty common thing that almost everybody has. Well, turned out this thing called Reserve Officers Training Corps, ROTC, was a pretty good deal. And I thought this was fair. I'll give the Navy 4 years. In fact, I was going to make it 4 years and a day, and I would get a college education. And I thought, hey, that sounds good. So, okay, so you get out, and I got to tell you a story of my very first Navy command, because although this was my first ship, it wasn't quite my first set of orders. I had no idea what orders were. You know nothing. Even though you know nothing, you really do know nothing. And so I get the set of orders to the USS Fisk, DD-842, and it's in Norfolk. Do I look up in where it is? Of course, now we have Google Maps. There were no Google Maps back then, but I figure, hey, largest Navy base in the free world. How can I possibly go wrong here? Get down to Norfolk. I cannot find the Navy base. True story. I cannot find the Navy base. I'm driving around. It finally gets dark. I ended up in places in Norfolk, and I've been stationed there a few times. I still don't know where I got that first day. But anyways, I finally get to the Navy base, and I'm looking for, kind of like, has anybody seen my ship? Looking for a ship with 842. I don't find it. I finally go find a duty officer, and he just kind of starts laughing. It's like, why are you laughing? It's like, well, they decommissioned that ship about a week ago. It's like, okay, here's a great start to a naval career. So what am I going to do? Well, long story short, I ended up on this ship, USS Farragut. And what I found out was I kind of like this Navy gig thing. In the Navy, in the military in general, you get an awful lot of responsibility really quickly as a young kid, and I like that. I like the sense of purpose. I like the sense of purpose of the Navy. I like the sense of purpose of the ship. I like the camaraderie of the wardroom. You start learning a craft. We called ourselves ship drivers, surface warfare officers, and it was pretty cool. And you got to work out on the ocean, and you got to work out in the weather. So my 4 years in a day plan gradually changed to, well, maybe I'll do this until they throw me out, or it stops being fun. Well, it's still fun, and they haven't thrown me out yet, so we kept on going. I transferred over to the Oceanography program. It's where we do all the weather forecasting and ocean stuff, and you start doing some forecasts first, maybe for individual ships or aircraft, and gradually you get to do more for larger type operations. Now, I never forecast for D-Day, but you do get to actually go and tell people, hey, you can't do this here. You got to go move in other places. So what we eventually started to figure out here, and this was a few years ago, is myself and working with my boss at the time, a guy named Admiral Tim McGee, is what we put together is something we call Battle Space on Demand. And what's that? With apologies to Karen Clark, really what we're doing when we're operating in the military out in the environment is we're operating in nature's casino. I intend to count the cards. The hard part is there are way more than 52 cards. The good part is there are no big guys with crowbars waiting to break your kneecaps if you figure out how to do this. So why do we do this? Why do we do this? Is because we can use state-of-the-art forecasting, put this into parameters that people care about. So like in the Navy, that means like finding submarines or finding pirates or whatever it is for the day. And then you make a decision. And you can give our forces a warfighting edge. That's what we do. That's what we do. So we thought this was pretty good. So meanwhile, what's going on? Well, this whole climate debate is going on. And frankly, I'm listening to it, but it's not all that interesting to me. First, it's like, people talking about 1 or 2 degrees. And it's like, well, shoot, I mean, you go up and down 30 degrees in a day. How much can that be? They're talking about all these computer models. Now, I've been doing this weather stuff since I was like yay high. I have lived and died by those weather models. More died than lived, especially in the early days. I know how many snowstorms those things predicted in Penn State and how many we got. And that was at like day 3. So how are you going to tell me that this forecasted 100 years, how can you do that? Come on, guys, let's get real. And then, very frankly, there was like kind of this political overtone to this, and I just wanted nothing of that. But the evidence kind of kept mounting, and as this gentleman here, Winston Churchill, once said that, sometimes we stumble across the truth, but most of the time then we just pick ourselves up and carry on as though nothing had ever happened. So I thought, well, maybe since I've kind of tripped over some things here, maybe I should at least take another look at this. So what did I see? I saw that science had really progressed, like since the time I got out of college to the time, this is like 2005, 6, 7, the science had really progressed. The computer models had progressed. The Navy had sent me to the postgraduate school in Monterey a couple times, I guess to try to get it right, get a couple more degrees, and I started to understand like the difference between the weather, which is forced by kind of what you start with, or the fancy term would be the initial conditions, and the climate, which is forced by those long-term things, like what the sun is doing, what the ocean's doing, and you could call that the boundary conditions. And you shouldn't, just because you have some issues with one on the short term, doesn't mean you can't figure out the other one on the long term. And then you look at the evidence. you just started looking at the changes, especially up in the Arctic. Somehow you had to convince yourself if there wasn't something going on, then how did you explain all the changes that were being observed? Not just forecast, but actually being observed. Well, I wasn't going to use religion, but this is pretty close here. The good news is I will not give you a test at the end, but this is the radiative transfer equation. It's the radiative transfer equation. Why do I put that up there? I put that up there because it describes the basic and physics that have been known for 100+ years as to how the sun and our Earth, or any planet, you can use this on Venus, you can use this on Mars, it works, and the atmosphere all interact. So this kind of starts saying, hey, what's going on here? So, the first and the most obvious thing to look at is, well, is the sun changing? Because is the orbit changing? We know for a fact that the Arctic, like 55 million years ago, was a subtropical forest. That's way, way, way warmer than anyone's talking about now. So like, hey, Titley, why are you getting all wound up about this stuff? Well, what you look at is, hey, the orbit of the Earth is actually different. It's not exactly round. It kind of wobbles, and then the Earth kind of does this. And you add it all up, and what happens is you get a different amount of sunlight coming in, and that small difference makes a big, big difference to the climate. But we can look back over the last 50, 100, 150 years, and we're pretty darn confident that basically we know the orbit's the same. We know the sun hasn't been appreciably changing, like plus or minus 0.1%. Okay, that's not enough to explain the changes. And look at aerosols. What's aerosols? These are little tiny particles that can kind of stay in the atmosphere. What are they doing? Well, actually, because we've got the Clean Air Act and some stuff like that, we've actually taken them out. That actually, believe it or not, contributes to warming. Who would have thunk? This is like no good deed goes unpunished, right? But it doesn't explain maybe a quarter of the warming. That's about it, at the most, at the most. So you look at volcanoes. We know volcanoes absolutely can and do cool the atmosphere. But you look over the last 150 years or so, and yeah, we've had some big ones, Krakatoa, Pinatubo, Mount St. Helens, but it's been nothing out of the ordinary and nothing that explains what the data are showing. So it sort of gets you now down into greenhouse gases. And what's the one that's been changing? It's been carbon dioxide. Well, is it natural or man-made? We can actually tell that because there's these things called these isotopes that decay at different rates, and it turns out that the ones from the dinosaurs, people don't like it when it's dinosaurs because it's really, really old plant matter, but I call it the dinosaurs and the critters. When you put that back in the atmosphere, it's a different chemical composition, and we can measure that. We see that of the CO2 coming in the air now, it's more and more is the ones without the isotope, which means it's old carbon dioxide that we're putting back in, or old carbon we're putting back into the air there. So, but it's just a small amount. It's a trace. And in fact, you got to have carbon dioxide if you want plants. We kind of like plants because we like to eat the plants, and sometimes we like to eat the animals that eat the plants. So it's not like anybody's advocating for, hey, let's get rid of all CO2. That would be a very, very bad world. It would be cold and no plants would live. So carbon dioxide is really, really useful, even though it is only a trace. But what it turns out to be, in addition to being a trace gas, is very, very effective at changing the atmosphere behavior. And people say, come on, Titley, it's just so small it can't possibly matter. Well, let me give you another example of something that's really small. Now, these lady and Jen here on my right, your left there, how much fun does it look like they're having? Yeah, okay, maybe it's been another day in the Pentagon for them. I'm not sure, I don't know. But that doesn't look like they're having a lot of fun there. And that's why I would call that like a blood alcohol content of, what do you think? 0, okay? That's like blood alcohol content of 0. Now, let's change that here. And let's look at what maybe 0.04 looks like. Well, hey, guess what, guys? It just turns out that 0.04 is like 390, 387 parts per million, which is exactly today where we are with CO2. Now, do those folks look like they're having fun? Yeah, probably a little bit more. It's just a trace. How can a trace make a difference? Which ones do you want to party with? I'll just leave you with that. Okay. Fast forward to May of 2009, my boss here, pictured here, Admiral Gary Roughhead, asked me to come be the oceanographer of his Navy, and also asked me to start looking at climate change. Now, as I mentioned, I'd done the forecast for individual ships and like bigger operations, but now what my boss is asking me to do is like, hey, Titley, come forecast for decades ahead and for the entire Navy. It's like, no pressure there. So, but that's the challenge. That's what we need to do to really make sure that we get this right for our Navy. So, why do we care? Why do we care about climate change? And there's tons and tons of reasons, and I'll just give you 3 here today. The first and foremost is the changes in the opening of the Arctic. You can think of the Arctic as the 5th ocean. What I'm pictured here is the Bering Strait. I am someday, so help me God, I'm going to go down to 20th and K Street here in Washington, D.C., and I'm going to take a map of the world. And I'm going to ask the first 100 people that pass by if they can find the Bering Strait. What do you think the odds are? Yeah, exactly, exactly. Well, that's it. It's 60 nautical miles. It's between us and Russia, and it is the only entrance and exit to the Arctic Ocean on this side, basically on the Pacific side there. So everything has to go through here. How much is going through right now? Not much. Why? Because there's ice. Hey, guess what? I think the ice is going to be, we'll probably start seeing ice-free conditions by about the mid-2030s, and by the middle of the century, we'll probably start seeing 8 to 12 weeks or 2 to 3 months of ice-free conditions. Once you get that amount of ice-free time, the big shippers of the world are going to start really paying attention to this, because what they do is they're looking for guaranteed, no-kidding delivery dates. They do not tell their masters when they leave Yokohama, hey, when you get to the date line, look left, and if it looks clear, go, otherwise keep on going through the Panama Canal. That is not their business model. Their business model is reliability guaranteed. So by the time you get to 2 to 3 months, they're going to be doing that. And they're probably not even going to go through the Northern Sea Route or the Northwest Passage. They're just going to go straight over the top. And I can tell you here today that people in Iceland are thinking right now as to how do they become the Singapore of the 21st century. Because when you think about it, that's going to be the terminus. So why do we care? Well, that's a strait that could have the importance of the Strait of Malacca and the Strait of Hormuz, because if you have fossil fuels coming out, and we and Russia together control that strait, that's a big change. What's this a picture of? This is a picture of a glacier and some scientists that are studying it. Why do we care about that? Because what's going to happen to the sea level rise? In the 20th century, the sea rose about 8 inches. If you do the arithmetic, it's about 2 millimeters a year. Is that a huge change? No. Can we deal with it? Yes. Did we? Yes. Was it a big deal? No. Okay, that's cool. But what's going to happen in the future? Well, what's going to happen in the future, we're already up to 3.5 millimeters. That doesn't sound like that much, but again, do the arithmetic. That's a 50% increase in what the rate of rise was we saw in the 20th century. Why is that? Well, as the water warms and 85 to 90% of all the heat, the excess heat, is gone into the ocean, it goes to warm the water. What do warm things do compared to cold things? They expand, they get bigger. The ocean's getting bigger, so that's part of the sea level rise. The glaciers are melting, like around in the mountains and stuff like that. Yes, they are melting in the Himalayas. Yes, they are melting in Glacier National Park. Both of those are melting. But where's the real water? With apologies to Willie Sutton, why do you rob banks? It's where the money is. Why do we study these glaciers in Greenland? It's where the ice is. It's where the water is. And these glaciers are starting to fall apart much faster than anybody, even 2 years ago, thought they were going to do there. So this is going to be a huge issue. And potentially, we can see the seas coming up somewhere between 3 and 6 feet in the 21st century. 8 inches in the 20th century, 3 to 6 feet in the 21st century. Is that in the IPCC? No. Why? Because if you read the report, they said, we just don't understand the ice sheet dynamics, So all we're going to do is like just kind of figure out what the expansion of the ocean is and melt a little bit off the top. It's being shown in a variety of ways there that that is a gross, gross underestimate. So I've told my boss, Admiral Roughhead, sir, look at 3 to 6 feet. Now I have, no kidding, this is a true story, I have really had a really senior person come up to me and say, hey Titley, why does the Navy care about sea level rise? It's like, well, we're the Navy. We tend to build our bases at sea level. I mean, it's just kind of a fact of that's where you put ships. But it's more than that. It's the US infrastructure. Look at where our oil refineries are. Look at where those are. Look at, they're all around Houston, right? New Orleans. They're in the Back Bay out by Oakland. It's all at sea level. There's tremendous infrastructure that this will have an issue for. So we've got to think about that. Okay, with apologies to this guy on the right here, you remember him, Tip O'Neill? Okay, just like politics, all sea level rise is actually local. Sea level rise is local, and what that will cause us is you've got to pay attention to what's the land doing as well as what the ocean is doing there. The ecosystems, ocean acidification. Why do we care? It's not a huge change, but it's about a 30% change, but it's more change in 200 years than in 200,000 years. And if you're a critter or an ecosystem, you've got to adapt, and you've got to do that now. And if we can't figure that out, you've got to start then asking yourself, where do the 1 billion people get their food from? Okay, so we got a couple choices. We can either keep our gas on the gas pedal, you know, and kind of do the Thelma and Louise thing and run this really, really big uncontrolled experiment and kind of have plan B as hope. Or what I would submit is, once again, this man says that he has great confidence in the United States because we tend to do the right thing after exhausting all other possibilities. So I kind of like to think about the model of Apollo 13. It was a crisis. We rose to that challenge. We have ways to do this, and I would suggest the Navy is working this. We have our Task Force Climate Change. We have our energy initiatives. We are cutting back on our greenhouse gases. I would ask you, go to the National Academy's website. Take a look at America's climate choices. Read the summaries. Get involved. Tell your leaders what you think about this. And together, this is a huge challenge. It's the future. It's unknown. It's hard. But we can and we will figure this out. Thank you very much.